In this video, we'll explore the fascinating world of swarm intelligence and its application in Moltbook AI, providing insights into distributed problem-solving techniques and practical applications in AI systems.
Have you ever wondered how a colony of ants finds food or how birds migrate in perfect harmony? These are examples of swarm intelligence, a concept that mimics the collective behavior of decentralized systems. Swarm intelligence is a pivotal component in distributed problem-solving and has inspired many innovations in artificial intelligence. In this video, we'll delve into how Moltbook AI leverages swarm intelligence for advanced problem solving. Swarm intelligence is a concept that originates from observing the collective behaviors of biological systems like ant colonies, flocks of birds, or schools of fish. Unlike systems with centralized control, swarm intelligence relies on the self-organizing capabilities of its agents, each following simple rules. This form of intelligence is decentralized and robust, making it ideal for applications in areas such as robotics and artificial intelligence. By studying these natural systems, scientists have developed algorithms that enable machines to solve complex problems collectively, much like their natural counterparts. The core principles of swarm behavior include self-organization, decentralization, flexibility, scalability, and robustness. Self-organization allows swarms to develop complex structures without external direction. Decentralization ensures that no single agent oversees the whole process, making the system flexible and adaptable to changes in the environment. Scalability enables the swarm to function effectively, whether large or small, while robustness ensures that the system can withstand the failure of individual agents without collapsing. These principles are crucial in developing AI systems that can tackle dynamic and unpredictable problems.
Moltbook AI uses swarm intelligence to enhance its problem-solving capabilities by adapting the principles of natural swarms to AI environments. By integrating these principles, Moltbook AI supports distributed networks, allowing AI agents to collaborate in real time. This results in improved efficiency and speed in decision-making processes, as the AI can adapt to new data and environments dynamically. Moltbook AI exemplifies how swarm intelligence can be harnessed to create robust AI systems capable of tackling a wide range of challenges. Nature provides numerous examples of swarm intelligence, each demonstrating unique problem-solving strategies. Ants, for instance, can solve complex pathfinding problems when foraging for food. Birds often fly in V-shaped formations to conserve energy during migration. Bees exhibit swarm intelligence when optimizing their routes for nectar collection, while schools of fish can evade predators by moving in unison. These natural systems display collective decision-making and problem-solving that inspire AI designs and provide valuable insights into distributed intelligence.
Swarm principles have been adapted into various AI applications, leading to significant advancements in technology. Swarm robotics involves multiple robots working in coordination to complete tasks that are difficult for individual units. Network optimization uses swarm intelligence to enhance data routing and resource allocation. Traffic management systems apply swarm algorithms to improve flow and reduce congestion. Environmental monitoring employs swarm drones for efficient data collection. Additionally, optimization algorithms inspired by swarm behavior solve complex computational problems, showcasing the versatility of swarm intelligence in AI applications.
Implementing swarm AI comes with its set of challenges. Developing complex algorithms that accurately mimic natural swarm behavior requires significant research and expertise. Ensuring effective coordination among numerous agents can be difficult, especially when scaling up the system. Real-time processing demands high computational power and efficient data handling to maintain performance. Additionally, achieving and maintaining the robustness of the system against potential failures or unexpected changes in the environment is a continuous challenge for developers working with swarm AI.
Swarming AI systems offer numerous benefits, making them an attractive choice for tackling complex problems. Their enhanced flexibility allows systems to adapt quickly to changing environments. The improved adaptability ensures that AI can learn and evolve over time, leading to better performance. Scalability allows systems to grow in complexity and size without losing efficiency. Resilience to failure ensures that the system remains operational even when individual agents fail. These benefits make swarming AI systems highly efficient and capable of solving problems that traditional AI might struggle with. The future of swarm intelligence and technology is promising, with ongoing advancements and research continuously pushing the boundaries. Emerging AI technologies are increasingly incorporating swarm principles to enhance performance and adaptability. In robotics, swarm intelligence is paving the way for more autonomous and cooperative systems. The integration with the Internet of Things, IoT, expands the potential for swarm AI to manage complex networks of devices efficiently. As autonomous systems become more prevalent, swarm intelligence offers a robust framework for their operation. The continued research and development in this field promise even greater innovations and applications in the future. In conclusion, swarm intelligence offers a fascinating insight into how collective behaviors from nature can inspire advanced technological solutions. By understanding and applying these principles, we can create AI systems that are more flexible, scalable, and resilient. As we look to the future, the potential for swarm intelligence in technology is vast, promising new innovations and solutions to complex problems. If you found this video insightful, don't forget to like, comment, and share your thoughts or questions. Subscribe for more content on cutting-edge AI topics and let us know what you'd like to learn about next.